Alright, how you doing today, boys and girls? Today we're going to take a look at finding and using slopes of lines. So this should be a review from Algebra 1 for you today. So let's go ahead and get right into this. One of the first things we're going to do is we're going to remember what the slope formula is. Now the slope formula is sometimes called in Algebra 1 rise over run. It's often referred to as change in y over change in x. Some courses that you'll get into will have it listed as delta y over delta x. That's what that little triangle means, delta, which is a Greek letter d for change. Or it could be in the form of y2 minus y1 over x2 minus x1. So those are a quick little review of slope right there. Now, when we take a look at the shape of the four slopes of lines in the coordinate plane, we're going to have several different examples. First one, negative slope. That line is going to be slanted just like this. It's going to be slanted. A lot of times people say it's slanted downhill. So negative slope will look similar to that. A positive slope will be going uphill on a coordinate plane and have a slant like that. A zero slope. Now when you have a zero slope, that's just a horizontal line. Now it could be above the x-axis, it could be below the x-axis, but zero slope will look like that. And then undefined slope. On the coordinate axis, your undefined slope is going to be a vertical line. And it could be on either side of the y-axis. So those are the four slopes of lines in the coordinate plane. That should look familiar to you, so let's go ahead and take a look at a couple of examples while we get into this for today. Now, first example, we're going to find the slopes of line A and D, and we're given a graph. Now we're going to do this two ways. We're going to do it using the formula, and then we're going to verify it also using the graph. Now if we take a look at 2 points that are on line A, so I'm going to take a look at this point right here, which has the coordinates, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So the coordinates of this spot right here are going to be 8, 2. So let me write that over here. We're going to have 8, 2 is one of my coordinates, and then my other coordinate is going to be at 6, 4. So those are my two coordinates. So when I go to find the slope of line A, when I go to write it, I'm going to write M for slope, and since I'm finding the slope of line A, I'm going to write a little a right there, because that's what we want to do for our notation. Now the slope formula says y2 minus y1, so we're going to have 4 minus 2 over 6 minus 8. So now in the numerator, we're going to have 4 minus 2, which is just 2. And then 6 minus 8 gives us negative 2. When we reduce this fraction, we get negative 1. So the slope of line A is negative 1. Now when we go to take a look at the slope of line D, now line D, so we'll write M of D, we're going to take a look at that, and that has, you can see it's a vertical line here. Now the coordinates for line D, for the 2 points that we can see on there, there's a whole bunch of points, but the two we'll pay attention to will be the point 6, 0. So we're going to use 6, 0. And then the other point we're going to look at is going to be also 6, 4. So when we go to find the slope of line D, we're going to use those 2 points, and if we go ahead and do our arithmetic there, I'll have 4 minus 0 over 6 minus 6. Now 4 minus 0 is just 4, and 6 minus 6 is 0. Now this is where some students will run into a little bit of difficulty. They'll think that 4 over 0 is 0, and that's just not correct. 4 over 0 is undefined. So let's go ahead and write that term down, undefined. Now at this point in your math careers, 4 over 0 will be undefined. Later on you'll learn how to work with a number divided by 0, but that's reserved for a calculus class much later in your math careers. So we've got those two slopes determined, the slope of line A and the slope of line D. Now, if we wanted to take a look at that graphically using what a lot of teachers refer to as rise over run technique, I could start here with this point and I could kind of go this way and this way. And when I do that, I just have to make sure that I count correctly. So in counting, I go up 1, 2. So I'd have 2, but then my rise is 2. So then the run, when I count from here to the left, that has a run of negative 2 since I'm moving left. So negative 2 divided by 2, well, that gives me negative 1, which is what I got for my slope for line A. Now my slope for line D, since that's a vertical line, you should recognize any time that you see a vertical line. So this line right here, line D, anytime you have a vertical line, the slope of that line is going to be undefined. So that's a quick review of finding the slopes of line A and line D. We've got to define a couple of things, and again, this should be a review for you. So if you need to hit pause while you copy this down in your notes, that's great, and I'll go ahead and read along for those of you that want to continue together. Parallel lines. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slopes. Any two vertical lines are parallel. Now remember from our last example at line D, vertical lines are going to be lines that simply are vertical. So if you see two lines like this in the coordinate plane that are vertical, you can assume that they are parallel. Now perpendicular lines are a little bit different, and you can see from our diagram over here on the right where we've got m1 times m2 equals -1. And what that means is when the slopes for these two lines, when you multiply them together, you should get -1 for an answer. If you don't, then the lines are not perpendicular. So in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Horizontal lines are perpendicular to vertical lines. And that just kind of is a common sense thing. If you draw it out, a horizontal line will be a line that has a slope of 0, and then a vertical line is going to be a line that has an undefined slope. So they are going to be perpendicular. Now let's take a look at example 2. Now find the slopes of each lines, which one are parallel. So we're going to kind of do this old-fashioned way here for a second. First we'll take a look at it from a slope perspective using the formula, and then we'll take a look at it graphically also. Now when we go ahead and calculate the slope, we're going to use the points that were given, and we can see those right here, so in 3, 0. So the slope for line A is going to be 4 minus 0 over -2 minus -3. Now 4 minus 0 is just 4, -2 minus -3 gives me 1, so I'm going to have a slope of 4. Now let me double check that graphically and see if I did that correctly. So if I start here, 1, 2, 3, 4, so my rise is 4, but then I start there and I have a run of just 1. So 4 divided by 1, yeah, that gives me a slope of 4. Now let's take a look at example B. For example B, I'm going to have the coordinates, let's see, 1, 2, 3, 1. So I'm going to have the coordinates 3, 1. And my other coordinate is going to be 4. Let's see, I've got 1, 2, 3, 4, 5. I'm going to have the coordinate 4, 5. So again, I'm going to have the slope of line B. Let me write that a little bit neater. I'm going to have the slope of line B, and that's going to be equal to 5 minus 1 over 4 minus 3. And when I do my arithmetic, 5 minus 1 is 4, 4 minus 3 is 1, I get 4 again. Now the slope of line C, so now I'm going to have to go over here to line C, and I'm going to take a look at this. So I've got 1, 2, 3, 4, 5, -2. So I'm going to have 5, -2 as one of my points, and then I'm going to have 6, and that goes up 1, 2, 3. I'm going to have 6, 3 as my other coordinate point. So let me move this a little bit right here. So when I go ahead and calculate the slope for line C, I'm going to have 3 minus -2 over 6 minus 5. Now 3 minus -2 gives me 5, and 6 minus 5 is just 1. So when I simplify that, I get a slope of 5. So which lines are parallel now? Parallel lines have slopes that are the same, so that means line A and line B are my parallel slopes. So when we go ahead to write that, that should look like this. So line A is parallel to line B since they have the same slope. So make sure that you show your work just like that, calculating the slope of line A, the slope of line B, and the slope of line C algebraically, and then be sure that you write a sentence to justify your reasoning. Now, let's go ahead and take a look at our next one. Now for this one, we've got line H passing through these 2 points, 3, 0 and 7, 6. Graph the line that is perpendicular to h that passes through the point 2, 5. So let's go ahead and plot our 2 points first. We're going to have the point 3, 0, so 1, 2, 3, 0, and 7, 6. So that's 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6. So 7, 6 is going to be right there. Now, I want to graph the line perpendicular to h that goes through the point 2, 5. So the point 2, 5, so 1, 2, 1, 2, 3, 4, 5 is right here. So let me go ahead and draw a line that connects the two that are part of my line. So I'm going to have these pieces of information. Now, one of the things that we want to remember is that from our slopes that are perpendicular to a given line, they're going to have negative reciprocals. So the first thing I need to do is actually find the slope of the line I'm given. So I've got my 2 points here, 7, 6, and 3, 0. So I'm going to calculate that slope. So line H passes through those, so I'm going to have the slope of line H, and that's going to be equal to 6 minus 0 over 7 minus 3. 6 minus 0 is 6. 7 minus 3 is 4. When I reduce that, I get a slope of 3 over 2. Now, the slope that I want, though, that's perpendicular through H that passes through that point, I want that slope to be the negative reciprocal of 3/2. So I'm going to write slope I want equals negative 3 over 2. So from this point, I want to create a slope that is negative 3 over 2. So I go down 1, 2, 3 over 1, 2. Down 1, 2, 3 over 1, 2 again. Now I'm running out of space on my grid, so I'm going to see if I can go up 1, 2, 3, and over 2. And that would be off the grid as well. So my line would actually be right there. So that would be the line that is perpendicular to line H that passes through the point 2, 5. And all we had to do was use slope for that. If you understood that, that's pretty good. All right, now let's go ahead and take a look at example 4. We've got line M passing through the points negative 1, 3, and 4, 1. Then we've got this other line T, which is going to go through the points negative 2, negative 1, and 3, negative 3. Are the two lines parallel? Explain how you know. So we don't have a graph or anything, so what we're going to have to do is just use a slope formula. Now what I want you to do is make sure when you show your work for the slope formula, pay attention to the technical details. So you might want to look at the next piece before you actually write the slope, just so that your work is organized the way it should be organized. Now when you do organize your work, this is how it should look. You've got the slope, and then the little m is for line M, and then you show your formula and calculate that for each one of your two lines. Now when we take a look at these, we've got a little bit of information here asking, about the slopes. So what you want to do is analyze that. Look at each one of the slopes. The slope of line M is negative 2/5, and the slope of line T is also negative 2/5. So if the slopes are equal, then that means that the lines are going to be parallel. So what we have to do then is go ahead and write a statement about that. And the way that you write your statement would look just like this. Since the slope of line M is equal to the slope of line T, the lines are parallel. So that's it for example, or for section 3.4. So hopefully you got all of this. If you did, great. If you didn't, that's all right. No worries. Go back, rewind, take a look at it again. But make sure, what I want you to really make sure that you do is take a look at the technical pieces to make sure that you show how to correctly find the slope by writing M in front of your formula. Don't just start off writing a bunch of numbers, because a lot of algebra teachers or geometry teachers, they might ding you for that and take a point off here or there. So make sure your technical writing is really good, because when you get into other courses later on, your writing for mathematics is going to need to be that solid. All right, that's it for today for this example. Thanks so much and have a great day.